Okay, so I'm going to kind of just talk about something from chapter 1, just because I know there's some students that hadn't had Java for programming 1, but I just want to go over the Java structure, which is kind of important to know, because some programming languages, or Java is kind of written a little different than other programming languages, and that is, where are you? Wait, pass it up, take it. Okay, it's this right here. Okay, so in Java, every file has a class, right? I know the last time we met, we talked about enumerations. An enumeration is considered also to be a class, right? So it had that enum was considered to be a class. But if you have a file, you have to have a class name. Is that true? Do you have to have it? I'm pretty sure you do.
Yeah.
I'm just trying to think if there's ever like a file that just has like constants in it. But I don't think I've ever seen that. They're always like inside of a class or something. Yeah, I could, yeah, I can do that. But I'm 100% certain that every file has to have a class, right? So whatever you name your file, you got to name your class, okay? So in Java, you have your class structure, and then inside of your class, you're going to have variables and methods, okay? And then inside of your method, you're going to have your programming statements. One program has to have the main method, so whenever you run a Java program, the entry point for your program is going to be the main method. Now, IntelliJ, it's kind of quirky where you actually have to tell it what main method you want to use. I know, like the last time I did this, I had to come over here and click here and then edit my run configuration and choose the correct main method to use. So you always have classes. Now, not every class is used as a blueprint for an object, right? Like some classes can just contain what we call utility methods, which are just methods that we can invoke to perform some task without having an instance of that object. Okay. Well, that's the way Java is kind of laid out. All right. That's what I'm talking about from chapter 1. Now let me open up chapter 4. All right, I'm just going to just kind of go through these slides. I'm going to maybe be a little slower on chapter 4 because it's just so important. All right, anatomy of a class. Okay, here it's telling you, like just what I said before, is that a class that contains a main method is just the starting point of the program. True object-oriented program is based on well-defined classes that represent objects with well-defined characteristics. So here they're giving you some example of classes where if you're writing a program that had a student, then perhaps some attributes of that student object would be the name, address, major, GPA. A rectangle would be length, width, color. Aquarium, they have their dimensions for the aquarium. A flight has all this flight information. Employee has like employee information. Okay, and then some operations, right? Some things that it can do. They also call it behaviors. Would be like any methods that you can invoke on that object. So for a student, you'll have your getters and setters, and then a compute GPA. For the rectangle, you'll have your just the getters and setters. Aquarium, you'll have the getters and setters for all the attributes, and then you'll have like these methods to compute the volume and compute the field weight, right? The weight of the aquarium when it's filled with water. And then for the flight, they have the getters and setters. Current status, determined status. I wonder what that means. Yeah, I don't think that's actually a getter or setter. Maybe it's just like some method they have to compute the status of the flight. And then for the employee, they have getters and setters for the department, title, salary, and then like they have some methods that you can invoke to compute wages, bonuses, and taxes. Okay, here they give a perfect example of an object. Like I always like to start with this object because it's something that you can visualize, right? So here they're talking about the like writing a class for a die. So if you think about a die, it's something that you interact with every day, or not every day, but I guess if you have a gambling problem every day. But a die is something that we've all interacted with, and if we sat down and thought about like the characteristic of a die, its behaviors, we know that a die only has a possible of 6 values, right? It'd be 1 through 6, right? Like at least a normal die, not like 8-sided die or anything like that. But we know like it has a face value, like whatever's showing, like whatever's on the face, like showing up, would be the actual value of the die, and that's something between 1 and 6. Okay. Other things that we can do with the die is we can pick it up and roll it, which essentially just randomly chooses a number between 1 and 6. Then some other things that we can do with the die is the way that we set the die would be like calling a setter for the face value would be if we were to pick up the die and we'll just randomly, or not randomly, but just choose a side that we want facing up. Like, so you pick it up and you say, oh, I want it to be 5. You set it down where the 5 is facing up, right? That would be like the set on the die. And then the get would be like if we actually looked at the die, we read the face value, and then us interpreting that face value is the actual get. So if we were to actually make a class for that, it would actually be pretty simple because that's something that we can visualize. Like, like those are characteristics that seem simplistic. So what I'm going to do is I'm just going to write that class really quick. I'm not going to use IntelliJ. I'll use Notepad++ since it's a simple class. Dang it, I'm all the way up here. All right, so in simple demos, I'm going to write a class called die. Okay, so this class is a blueprint object for an object, and the object is going to be die. So really the only attribute of this die, I mean, we could have color if it's going to be like for a video game, I guess, right, where we want it could be red or black or white. But for us just to interact with it through command prompt, really the only attribute that is necessary is the face value. So I'm going to say private int face value. Bam. And then my constructor for the die would simply just set the face value to something that makes sense. So something that makes sense would be either 1, 2, 3, 4, 5, or 6. So you can come up here and like make constants for the min and for the max. Okay, but it's up to you really. But I'll go ahead and just make a public static final num of sides, and I'll say the number of sides of this dice is 6. Now the reason why I made it a final, actually I didn't actually give it a data type. Okay, so the reason I was able to make this static and public is because I said it's a constant, meaning that the value will never change. Once you set that value, it can never be changed. So you don't really violate what we call encapsulation by making this public. Okay, I'm making it static, so that all that means is I don't have to have an instance of the object to call that variable. I can just call it straight through the class name to get that value. And then some other methods I'm going to have are just the getters and the setters. So I'm going to have a method called public void set face value, actually public void set face value. Okay, and we'll just take an int for the value, and then I'm going to put like a filter here, and the filter is going to be if the value is greater than or equal to 1 and the value is less than or equal to, I guess we could put number of sides, right, which is essentially 6. And then here, if all that is true, then I'll go ahead and I'll say set my face value to the value that was passed in. Okay, and the getter for this is pretty simple. You'll just get face value. All right, and the roll method, this is where I think I talked to you guys about using the math random class. This could actually be like super simple by just saying public void roll And all we're going to do is set the face value to a number between 1 and 6 randomly. So I'm going to say face value is equal to math.random, which is a number. Math.random gives you 0 to 0.9999. So I want to multiply it to the number of sides. Okay. Then what I'm going to do is cast that result to an integer. Right, because what's in parentheses is going to give me 0 through 5.9999, right? Cast it to an int will just give me 0 through 5, and then the last step would be to add 1 to it. All right, and that's rolling, right? Just randomly setting. I can do my toString and all that stuff. I'm not going to do that. Actually, let's talk about the equals method. So what do you think would make one die equal to the other? If I had a die here and I had a die over here, what would make those two die equal? Yeah, face value is the same, right? This is a really simple one to write an equals method for. So I'm going to override the equals method on the object class by just saying public boolean equals take in an object, then make sure that the object is an instance of a die. So, what can I do here? Man, totally forgotten. Drawing blank. Okay, yeah, object, instance of, and say die. If that is a case, then I know that I can have die other, which is equal to die being casted to, or object being casted to a die. And then I can just return this dot face value is equal to other dot face value, right? A real simple equals method. And then out here, if you're not an instance of a die, I'm just going to say we're not equal to each other. All right, return false. Okay, so I know there's some questions about just coming over here and typing die. Now, I agree with you, that does work, and that's probably the way I would probably do it. But we're not technically overriding the object class's equals method if we don't do that. Okay, we're just what we call overloading. So I don't know. I just want you to do it like this for this course because I want to see like you do something about changing this object to an instance of a die.
Wait, so you're saying like throughout the course you would want us to use object instead of the actual name of the class?
Yes. Yeah. Does that I want to make it as complicated as not as complicated, but just so you can kind of get used to checking to see if something is an instance and then casting it to a die. Okay. All right. But I agree with some students who said, why don't you just pass in a die, and then if you pass in like a string, then this is going to use the objects equals method, which will return false. But I guess for getting used to like casting objects from a generic object to a more specific object, I'd prefer you to just completely override the parent's equals method. All right, and all this is going to do is all it's doing is making sure that the object coming in is a die, and then once it figures that out, it's going to cast that object to a die and then return if face values are equal to each other. All right, so this is what's going to return me a true or false. So if this die coming in has a 5 and the current dice being compared to is 1, then this is going to return a false. All right, so let me just write a driver class to test this. So I'm going to come over here and make a new file, and I'll save this as dice game. All right, and I'm going to say public class and dice game. I'm going to instantiate die 1 to a new die, and then also instantiate die 2 to a new die. And then I'll just roll these numerous times. So say for int x is equal to 0 while x is less than, let's roll it 25 times, x plus plus, and then I will say die1 dot roll, die2 dot roll, die1 value is, and then oops, dang it, die1 dot get face value. Oops. All right, and then I'll just say die2. Yeah. Oops, I didn't name it right here. I'll just say like die number 1, die number 2. All right, and then I'll just check if they're equal. Okay, and I'll just say, this is what I'm gonna do. I don't know if you guys use the ternary operator, but I love using ternary operator. That is from chapters 5 and 6. I'll talk about it, I guess, when I review 5 and 6. But basically what you do is you just examine a condition. You have a true or a false value that comes out of that operator. So what I'm gonna do is I'm gonna say, okay, well, compare die1. Check to see if die1 is equals die2. That's gonna give me a true or false. Okay, if it's true, I'm going to say something. If it's false, I'm going to say something here. Okay, I'll just say dies are equal, or dies are the same, and then I'll just put this over here, and then I'll put like dies are different. All right, so I'm going to compile. Let me open up my command prompt. Dang it. Ugh. Hold on. Okay. And Java 2. Simple demos. Oh, shoot. Okay. So I'm going to compile this by saying Java C, and then the name of the class is Dice Games. So I'm gonna give it the name of the file. Dang it, didn't compile. So type is not allowed. What did I do wrong? It's not print line. Oh, void type is not allowed. I don't have a return on my get. Oh, dang, I'm sorry. So I put void there for some reason, right? So it's basically telling me that it's expecting a string, right? Or some value, but the way I had my getter set up was the face value was coming back was void, which means it doesn't return anything. All right, let me clear my screen. Try it again. All right, and then compile. All right, so it ran it. I should have put some space here. Yeah, let me just make this look a little neater since it's Java 2, so we should take a little more pride in our outputs. I'll just say like, yeah, I'll do something like that, and maybe put an additional line, and then maybe like right around here I'll put the roll, which is x plus 1. All right, save that. All right, so I rolled it 25 times. They're different. Here they're the same, right? Just because of the face value, and so on. Okay. Dang, I only hit it one time. Same. Yeah, so it looked like 4 times. But I mean, if I wanted to count how many times they actually were equal to each other, dang, how am I gonna do this? Okay, so I'm gonna do, I think I can do this in Java. I'm not sure. Okay, I'm gonna say int count. Actually, now I'm thinking about it. I don't know if I can actually do this. Okay, so this is going to count how many times we got equals. So, okay. All right, I'm going to have to just make another ternary operator. So I'll just say thing. I have to do this. I'm going to have to recheck it, which I don't like doing because I'm basically calling that method twice. So I'm going to come over here and I'll just say is equal, and I'll just set it there, and that way I can use that variable here and here. And then I'll just say like count plus plus, and then whenever it finishes, number of times equal. All right, just to keep track of. Dang it, nobody caught that? Where was that? Oh, right here, the last thing I did. All right, and the number of times they're equal were 6. That way I have like better idea of what's going on inside of this loop. But anyways, this is kind of a perfect example of writing a class. It's something that's like easily visualized, I feel, because it's easy to visualize interacting with a die object. So let me hop back over to the PowerPoints. All right, and they give you this example. They tell you about classes here, and they do their own example of rolling the dice. All right, so the toString method. This is something that we override in order to print something that's meaningful for the actual object that we're writing it for. So for instance, if I were just to print out the object straight to the console, I just say after I instantiated them in my dice game, like right around here, before I enter the for loop, and let me just take this down to something a little more reasonable. We'll just say roll the dice 3 times. Okay, so come over here, system out, print line. Now what the toString method will do, it's going to print out your object die. It's gonna convert your object to a string. Okay. Now, if you don't overwrite it, like I don't have the toString overwrite it over here. Okay, it's going to call the object's underlining toString class. Now, the toString class gets called whenever you concatenate your object to a string, whenever you pass your object to something that requires a string, like print line, or whenever you just manually call it by just saying like die2 dot toString. Okay, like invoking it like that. Now, if we look at our die class, once again, we never overwrite our toString. So when I hop over here, clear my. All right, and this is what I get from my values. All right. Now it's just really just where it's at. Okay, in memory, it's saying like it's a die object. Actually, let me clean up my output a little better. I should put a colon here and a space. Colon here and a space. All right, try this one more time. Okay, it's basically printing out the class name and then the location of where that object is in memory. Class name, the location where the object is in memory. If I want something more meaningful, I could come over here and to my die class and just override that by just saying public string, because you're going to return a string, toString, and then return, and then just make up some string here. I like to use string.format so we can visualize what we're actually going to output. I can put the name of the class, right? Then maybe like some square brackets, and then say what the face value is. Okay, and then do a %d because the face value is an integer, and then right here pass in face value to be placed into this location where I'm putting the %d. I can save that, come over here, clear my screen, compile, run, and then now you can see I have the toString method being used that I just used in my die class. Right? It's no longer using the objects underlining toString. Same thing with the equals method. If we do not override the equals method, if I didn't create this, then it's just going to use the objects underlining equals method, which simply just verifies to see if it's the same object in memory. Okay. All right. Let's see, chapter 4. That's toStrings, constructors. All right. So we use constructors to set up the object. So normally what we do with the constructor is if there's any variables that need to be initialized, then we will come to our constructor. Dang it, where am I right here? Go to our constructor and initialize into something that makes sense. Now the reason why I did this here is just to show like me using the constructor, but you can also just do it here. Like if you wanted to set this to 1, okay? And then if you don't have a constructor defined, Java automatically has a default constructor that just does nothing, just puts the object into memory, okay? Because you're inheriting from your underlying object class, so it's inheriting your object's constructor, the generic object's constructor. So I'm gonna hop over here, I'm gonna clear my screen, compile, run, okay? And it works just the same, right? And all I did was just move it out, okay? Now it's up to you on how you wanna do it. I prefer to just initialize everything inside of the constructor. Okay, I don't know, but I'm not gonna like ding you for anything unless the problem tells you specifically to write a constructor that does something. Okay, then you're gonna have to take in some value for the constructor. Let's see, yeah. All right, so chapter 4. Okay, they talk about data scope, but I think that's a pretty easy concept. It essentially just means like if you create a variable inside of a method, that value only exists for the duration of that method. Meaning anything that we created inside the main method goes away after the main method ends, right? So anything we create inside of this roll method will go away after the roll ends. We don't have any variables declared, but let's just say that I did something like this. I just said like double random with offset. No, not offset. I'd say random num. Okay, and random num will be equal to math times number of sides, and then I decided to use that here. Okay. Now, what we store inside of this variable is getting put into memory, but it's actually going to go away once this method ends. Okay, so this is what we call like a local variable. It's local to this method, but we also have our instance data, right, which is a class variable, and it exists as long as that object exists. I never showed you the number of sides. So since the number of sides is static, I don't actually need, I can come up here before I declare any objects. I don't actually need to have an instance of the object to read that value. I can just say number of sides is, and then come over here. That's the name of the class. The way we use the math method, right? Very similar. I just say num of sides. Okay. And this is being called directly from the class name. Compile. Dang it. Nobody stop me. So I didn't put a semicolon. I've been using Kotlin a lot. And in Kotlin, there's no semicolons at the end of the line. It's just space, right? Like the next line is, like whenever you hit the new line character, that's the designation of how far the line actually goes. But I forgot to put a semicolon right here. So, sorry about that. All right, and there you go, right? I was able to grab that variable because it was static. Static means that it's attached to the class and not the instance of that class. I didn't have to have a die object to reference that value. Okay, so math, like all the math methods are all static. Like if I wanted to know what pi was, I can actually just grab that. Yeah, it's a variable that lives off the math class. So if I wanted to know pi as a double, I can just say pi and then call math.pi. Right, and then there's that value of pi they gave me. Dang it, I didn't put a space. Oh, I did. But anyways, you can see that value. Let me just add that space in real quick. All right. UML diagrams, this is actually kind of interesting to know. I don't think I'm going to give you any work on this though. It's just basically a way of laying out your classes. So for our die, we're saying, here's our die class. It has these instance data, and these are the methods that you can invoke on our die. Our rolling the dice class, which has the main method, is using our die class. Okay, encapsulation. So the idea behind encapsulation is keeping instance data private, right? So the reason why we make face value private is so that you can't just come in here and change this value to whatever you want, right? The only way to modify face value is to, or whoever's using this die class, right? Essentially the instance of the die, the only way that they can modify the face value of that die object is by calling set face value. If you call set face value, it's going to make sure you don't change it to a value that doesn't make sense. So, excuse me. So if I come over here to my driver, yeah, I instantiated my die right here, and let's just say that I said die1 dot set face value, and I passed in a 3. That is a valid value, so it is going to take. And then I'll say die1 dot get face value. Okay. So there's my value of my die, and I'm going to call set face value again, but this time I'm going to give it a value that doesn't make sense. So I'll just say I make this like negative. Excuse me. Oh, I didn't put negative. Put 1. Negative. 3,000 or 30,000 or 300,000. Something that's absolutely makes no sense at all for a die. Clear my screen, compile, run, and you can see that the value did not actually take, right? And the only reason that happened was because I'm encapsulating my face value. So I'm forcing, the only way to set this face value is by using the setter. So whatever value that comes in here, I'm filtering it out. I'm making sure it falls within a range. Now if I came over here and I made this public, okay, the setter is still going to do all the filtering, right? I can come over here. The setter is still going to work the same. Okay, you can see that die1 stayed 3, but I can bypass the setter now that it's public by simply just, let me copy this. By simply just saying die1 dot face value. Let's put like a couple of some nines in there, okay? So because this is public, right? I made it public. Now I'm able to access it directly through the instance reference variable, right? The object reference variable. So now when I come over here, I can clear my screen, compile, run, and you can see the value got set to that value, okay? So that's in violating the encapsulation. So the whole idea is you have this object, you have data for the object, you have a set of values that make sense for that data. You don't want to expose that data directly. The only way you want to expose it is through methods to change it so that you control like the range of what those values get set to, right? That's the idea of encapsulation. So the way that I like to think about this is, let's just say you're writing a program for a student, okay? So this student class is actually attached to a database that says, your GPA and your scores and all that kind of stuff. So whoever wrote this program, or you wrote this program, you're prompting the user for like test grades, right? Enter this, enter that. Okay. Now if you enter something like 10,000 for his test grade, like if you're using your setters correctly, you can filter that out and say like that's an invalid value. It's outside of the range, right? But if you were to violate encapsulation, meaning like perhaps you named the instance data or made it public, now you can access that data directly through that object, and you're using that to set your face value, and you didn't do any type of filtering from the data being entered, then the user will be able to change the value to whatever he wants, right? You could enter a test grade of 10,000, right? So the idea behind encapsulation is by maintaining the integrity of your data, right? So that's why in classes, our instance data is always private, and the only way that you can change this data is through public methods, right? So set face value. Or the other way we can change it is by this public method, roll. Right? This controls what random range we set that die to. All right, those are the visibility modifiers. So we have, actually, now I need to talk about all of them because we're going to talk about protected. Okay, let me read this now. Okay, so I think the first, when I went over this for Java 1, I only talked about public and private, but now I can talk about protected, and then there's like a default one where you don't specify, if you don't specify the modifier, it uses like this other type. So technically there's 4. So in Java, we accomplish encapsulation through the appropriate use of visibility modifiers. A modifier is a Java reserved word that specifies the particular characteristics of a method or data. We've used the final modifier to define constants. Java has 3 visibility modifiers: public, protected, and private. The protected modifier involves inheritance. We'll discuss that later. Okay, so, right here. Members declared without a visibility modifier have a default visibility and can be referenced by any class in the same package. Any class in the same package. Okay. All right, so I want to demo what all that means now. But we were going to talk about that whenever we cover inheritance. So this might not make a lot of sense now, but I'm going to go ahead and type up an example for this. So I'm going to come over here, I'm going to go to new project, and I'm going to name this one next. Let's see, next. I'll call this one visibility test. All right, so what I'm going to do, and one thing that we haven't really talked about yet, is having different packages. Now, a package is essentially just, you'll hear that term thrown around, but it's just essentially just a directory structure of where you're actually keeping your files. So if I come over here and I say source, and I'll just say package, I'll just say like, I don't know, edu, right? And then I'll just say NVC, and then I'll just say COSC. Okay, hit enter. So now I have this package of edu, NVC, COSC. I could make like another package on this thing called edu.nvc.itsc. Now, if when I'm doing this for the packages, now whatever I put in COSC, I can have a class called die, right? That lives in COSC, and I have a class called die in ITSC, and they won't they won't collide with each other as long as I use the correct package reference, right? So the die from ITSC might do something different than the die from COSC. Now, it doesn't, like, it seems kind of dumb to do that. I get it, but if you're using a bunch of external libraries, you know, one library might have a class called string utils, and another external library you're using might have a class called string utils, right? So which one do you want to use? Right, you have to actually specify the entire package name if you know, I want to use the string utils from Apache, or I want to use the string utils from Android, right? That happens actually a lot, especially with using external classes. But for your own class, like your own program that you're writing, it doesn't really make much sense to have two class names the same, but in different packages. All right, so I'm gonna come to the COC one, and I'm gonna make a class called, let's see. Dang, I'm running out of ideas. I'll call it enemy. Call that enemy. Okay, press enter, and then a public class enemy, and then the enemy is gonna have a instance data for, let's see, name, I guess. Okay, you have string name. All right, and string, you have string name, and that's all he's gonna have in this class. Okay, and then I'm gonna make another class here. And I'll call this one test enemy. All right. All right, and then I'm going to type my main method. Oh, what was the short key for the main method?
What was that?
The short key for.
The main method is the active.
Oh yeah, if you type PS, yeah, I just type PS and it's like the first option, right?
That's not it's just
Oh yeah, you're right. Sorry.
yeah, there you go.
There you go.
3 letters.
Press enter. Okay, and then it made that main method for me. So you avoid having to do that. All right, so I'm in this class is in the same package as enemy. So I'll be able to come over here and say instantiate enemy object called E1 is equal to new enemy. Okay, and then I'll be able to say like E1 dot name is Frank. He's my arch enemy from kindergarten. And I'll do system out print line. Actually, there's a shortcut for that too, right? So, oh yeah, right there. System out print line, and then I'll just say maybe name, and then E1 dot name. All right. It has a visibility of the default, which there's nothing there, right? There's no private, there's no public. So I'm able to see that as long as I'm within the same package. So if I come over here to run configuration and I add a run configuration. No, dang it. How did I do this the last time? Application. And then I had to specify in class. Well, just, let me see, enemy. Or test enemy. Test enemy, and then look for my main class right there. Hit OK. Hit OK. And now I compile and I run. My output comes down here. All right, and I was able to see Frank, right? All right, so if I come over to the other package, which was ITSE, and I come over here and I make a Java class and I call it test in ITSE, create it, and then type PSVM, and then come over here and instantiate an enemy. Okay, now it imported the enemy object, but it had to get the whole package because it doesn't live in the same package as the enemy. Over here, it said this was the package name, but it didn't have to import it. Over here, I did have to import it because I wasn't in the same package. Okay, and I'm gonna say E1, and I'll just say new enemy. All right, actually, IntelliJ is not gonna let me do any of this stuff, right? It's not even giving me the option to use name, right? On the other one, it did, and the reason why it's not showing it to me because IntelliJ is smart enough to know there is no visibility on enemy, so that means that it's not private, it's not public, but it's a default, which means only classes within the same package can see that data. I would have to make a getter and setter for the name if I wanted to use it over here. But if I come over
Set
here,
it to public?
yeah, I could set it to public. But once I name it to public, then when I hop over here, then I can just say enemy name is equal to Bob. And then let me just copy what I did over here. Control C that, slap it in over here, right? And everything will work fine. I just have to come over here and edit my configuration. I can't just add a new one, can I? Maybe let me add a new one, see what happens. Add a new one, all right. And I'll say ITSE test. Come over here and I'll choose this one. Hit OK, hit OK. Now when I run the ITSE one, right, the output is gonna be Bob. That's it runs. Give us time. Come on, you can do it. Right, the output's Bob. The only reason I can see it in ITSE is because it was public. All right. So that is what they call the default visibility, meaning you didn't specify anything, right? So if you don't specify anything here, then you won't be able to see it in a different package. Now what the protected does, if I made this protected, okay, I won't be able to see it in ITSC anymore, right? It's all red, it's upset. I won't even be able to see it over here. Dang it, I was able to. Oh, you know, protected is the same class and anything that inherits. That's what it is. So, or the same package and anything that inherits. So if I come over here and I make a new class, and instead of being enemy, it's going to be like something that inherits from enemy. So I'll just call it like a goblin. Okay, goblin. All right, so here's your goblin class, and the goblin is basically going to what we call going to inherit from the enemy class. So I'm gonna type extends and enemy. Okay. So now what's going to happen is I'll be able to use that enemy inside of this class, right? Because it's protected. So I can have a method called public string, or how about public void? No, I'll do string because I don't want to teach you guys bad programming habits. So public string, and I'll just call it like get name. And then here what I'm going to do is just return. And I'll just say like name, right? It's available, and that's going to give me the value of that name. So now I can come over here, and instead of instantiating enemy, I can instantiate goblin. Okay, and goblin is going to be a goblin that extends from enemy. And now what I can do is call get name, and I can run. And it's going to be Frank inside of this ITSC. So what happened was, dang it, it was null. What the heck? Oh, I never set it. Duh. Okay, I have to set this. So what I'm going to do is come over here and set it. So I'm going to make a constructor. Okay, and all I'm going to do is just say name is equal to Cindy. All right, I'll come back over here, compile a run. It's going to give me Cindy right here. Okay, so for protected, so the way the protected modifier works is you can see it within the same package or through inheritance, meaning the goblin can see the name only because it inherits from enemy. But if I came over here and I made name private, then if you hop back over to goblin, it's red, meaning it's no longer visible to the children of that class. Okay, now we're gonna have to know all four of those. Whenever we get to chapter 9, we'll talk more about inheritance. But wait, I didn't want to do that. What the heck? Control Y, Control Z. Dang it, I have no idea what I'm doing. Control Z, Control. Wait, Control Shift Z. How do I put everything back? Oh, dang, messed it up. But anyways, Frank is upset now. So I have to come over here and make this right. So, anyways, when we get to chapter 9, you're gonna have to know all 4 of these visibility modifiers. Private and public are the 2 ones from Java 1. The new ones that we have are protected and the default visibility. Okay, so default you can see within the same package. Protected you can see in the same package or through inheritance, right? Through like whatever child essentiates or extends from that class. Yeah.
I was just reviewing over here.
What's that?
No, it just felt like it was way off point.
Oh, I mean, we're reviewing, but like that was a topic in chapter 4, and I figured I might as well just touch on it. Okay, so that's it for chapter 4. I know I don't know how comfortable you guys feel doing the homework from chapter 4, but a lot of it is just coming here to the class, putting instance data, right? So like the I don't know what are one of the problems from chapter 4.
Make a flight plan.
Okay, the flight is actually pretty simple. I come over here, Java class, flight. Okay, it seems like a lot of work because it's a lot of problems, but like using IntelliJ makes it super easy. So you can just say like private, int. They had like data for the flight number, right?
Yep.
Flight number. Like that was one of the bigger ones, right? Maybe I'll just spell out flight number. All right. Dang it. Okay, and then they had like a string for
Airline,
or destination, right?
destination, and origin.
Yeah, destination or dang it, destination, private string.
Is there a particular reason you're not just using one line?
I don't know. I just prefer to. Okay, what else was there?
Airline.
For
The airline.
the name of the airline. All right. Anything else?
No, that's it.
Dang, only 4. It seemed like a lot in Java 1, right? All right. Okay. I don't. Well, now that we're using IntelliJ, it's just as simple as coming over here,
2 seconds.
hitting generate, getter setter, selecting all of this, hitting OK. All right. There's all your getters and setters. Now I do require you to put filters on your setters. So like for the airline, like what doesn't make sense for an airline?
Negative flight numbers.
Well, flight numbers, yeah, but an airline is a string, right? How about if it's coming in, it's not null, right? Like you don't want it to ever be like null, right? Like you're making sure that they're not trying to set it to something that is null. Null meaning like it's not set. So like if they're passing in a string that is not null for the airline, you know, and then maybe, I don't know, it's up to you, like airline is empty, right? So airline is not empty. Is empty is something you call in a string. It basically tells you right here, just click on it, dang it. Ugh. I don't have the touch. Let me hop back. Where's my back button? Dang it. There's a way to put a back button up here. So where you can just press it and hop right back to where you're at. Edit. Probably like view, tool, windows. I don't know. Somebody will figure it out, I'm sure. But I'll hop back over here. I'm going to hover over this, right? Or control space it. Okay. Hover over it and it gives me my Java documentation. It says returns true if and only if the length is 0. Meaning like there's nothing inside of that string. So I'm saying I don't want the string to be empty. Meaning you can't just pass in a blank string. You can't give me null, you can't pass in a blank string. Makes sense, right? For if you're taking in like a name of airline, probably do the same thing on the origin. The flight number was an integer. Where's the flight number? Flight number. All right, so set flight number is right here. A good way to filter that one is you want to make sure the flight number coming in is greater than, I don't know, 0, right? I guess you have a 1 for a flight number. Okay, or maybe if you know all the flight numbers are 4 digits, you can just say greater than 99 and less than that, right? Does that make sense? 5, so that'd be 999, or I can do greater than or equal to 9999. There you go. That'd be the max flight number, and this would be 1000 would be. Actually, I could probably just change this to 1000 to make it more readable, I guess. Right. So this is a minimum flight number I could have. This is the maximum flight number I have. Right. You could do something like that. I don't know. It's up to you. But you should at least make sure it's not negative for an integer, right? Because a negative doesn't make sense for flight number. Like that's what I want you to do is just add some filters there. And then last thing that you should also override your toString. toString, I'm not really going to check your toString, so you can just come over here and auto generate the toString, right? And that's fine with me. Okay, but I do want you to take some time and think about your equals method. You can come over here and auto generate it. I don't know, just whatever, like maybe all three. I don't know, maybe if the flight number equals the same, who knows? It's up to you, right? Dang it. Oh, we're saying these cannot be null. Oh, you know what? Like, check this out. So let's see, can't be null. So if you put like it can't be null, it's actually gonna check to make sure that I thought it was gonna put the annotation in there. Oh, I basically told it that I'm never gonna pass in a null for the flight, so it's not even checking to see if it's null. But anyways, you can get rid of this hash code one and just focus on this. I mean, I do want you to kind of write this out because I'm going to ask you this on your midterm. You know, however you prefer. I know I like to use the instance of over doing what they did. Here they're checking to see if it's null, or they get the class name and making sure that it's the same class name as the other one. If not, they return false, right? So one thing they're doing is right off the bat, they're just checking to see if they're the same object of memory, return true. If O is equal to null, or the class name is not equal to the class name of O, then they're going to return false. And then they cast it to a flight, and they just do this comparison. The instance of would have prevented you from having to do all of that, and then we could have just returned false out of that. Yeah. So it depends on, I guess, your approach, but that's the way you can generate the equals method. Pretty simple. IntelliJ does a lot of like the boilerplate code for you, so you don't have to spend a lot of time writing out getters and setters, like things that just are just repetitive and boring, right? You can have it all done for you. So I know I'm having you do like 9 classes, but really there isn't that much work that you have to do for those. All right, anybody have any questions? Okay, so that's all I have. Next week I'll cover chapter 5 and 6. You guys are free to go. Yeah, it's saved there. I messed up my enemy class stuff though. It's red right now. Let me try to fix it. Oh, I think I messed it up by changing this to private.